Hello, everybody. Thank you for joining for another session on the news on the Embedded Academy. Today, I would like to start with a different view. Today, we will have a look first on the YouTube channel because there are also some news and updates to be found there. So as you can see, this is our YouTube channel of Eclipseina. I start with the live streams. This is the event which is just happening right now. What I want to show you is that I did an update also in terms of introducing the Embedded Academy with an overview, also like an introduction with a background. Why did we do this? What's the purpose behind? Giving a complete overview and also explaining some conceptual approach. And this is also available on YouTube, where you can check the overall approach. This might be interesting. And some weeks later, we did another event introducing our learning journeys based on job profiles, where we explain how we provide the information and which job profiles are covered on our webpage. We've been working on the job profiles also before, but I think this is giving a very good insight in the overall content, which job profiles are available, how they are structured, and what to be found inside. So these are also options to inform yourself independent of what's new. So what's new is really focusing on the changes, and it's not giving you the conceptual view or the general view, because it is only a delta. Starting with these, then the delta is, I think, a lot easier to understand. In addition to this informational part, we also sometimes invite experts, and we did a series together with Protos Software, Thomas Schütz, who has been informing us about different topics, like, for example, architectural approach, continuous integration for embedded system. The last one was contract-based design, which is a very strong and good possibility to ensure that you are building a safe and secure embedded system, because safety and security is not just processes. You also need to get the technical stuff right. So these things you can find here. And you see here, this was the last time we did the What's New 3 months ago, but we have some technical talks in between as well. What we also offer is videos on various topics, and you see on the video line there are different topics. We have our regular glossary units, which we are publishing, and we have 2 playlists which we are continuously enhancing right now. One is the cryptography one, and one is on AUTOSAR. And the AUTOSAR is also going beyond what we offer within the Embedded Academy, because we currently the latest videos we've been generating was explaining the AUTOSAR standard part to negotiate to the right place. And then I'm going into the AUTOSAR standard itself on the website, into specifications, and give some explanation in addition to these specifications. So all this you find here. And of course, we structure it in various playlists. Yes, the second part of Eclipseina is the charging. We have some established charging playlists on our charging test systems in German and in English, and a broader one with more information on electric charging, also in English and in German. And what we saw there, where we publish in new content every month. Once every month is the classical cryptography line. It's a longer playlist, and we have AUTOSAR. AUTOSAR overview is complete, but for the classic platform, we are continuously adding content by giving extra information to what we are providing. And you see it has been updated 4 days ago. So we are continuously working on these topics. And on the Embedded Academy, you have the playlists with what I said, the glossary units, for example, and some learning videos. This is like the big playlist, including 52 videos on Embedded Academy free content. And there is the explanation. This playlist is providing you Embedded Academy, our Embedded Academy video, and all the trailers, which are referenced also. And of course, we also have Embedded Academy in German. So this is for the YouTube side, which you found and which you are joining right now, but maybe it's worth to have a look once in a while. So now we'll go to the Embedded Academy web page and look at the portfolio. So it has been growing, and this time we added new courses and also new content. I'll go down step by step. One big news is that AUTOSAR is now available as completely free course. So all the lessons are now available for free of charge. The only thing you have to do is you have to sign in. You have to create a login to be able to go through the course. And if you're not logging in, then it's just the first unit, which was for free also before. So it's this AUTOSAR course we are now offering completely for free. Overview, then the classic platform, revision 1911, introduction to the virtual function bus, and then the basic principles to the virtual function bus, which is the part which is implementing the real-time environment. And then also some operating system parts. You can see it here. And it's always the same. We have a description there, maybe then to say the target, what should you learn? Then we have a trailer, which is on YouTube, and some insights to have some pictures to understand what to be expected from this course. So we'll have a short look into it. Here you see also the whole course with the different units, being able to navigate. You can make the learning part bigger if you like. And then now we'll have a short look at just this one page to give you a feeling on what to expect here. No.
The main concept of the standardized ECU software architecture is the separation of hardware-independent application software and hardware-oriented basic software by means of the software abstraction layer, runtime environment. The runtime environment includes the control of the data exchange between these layers. This forms the basis for a component-oriented, hardware-independent software structure on application level, with software components as individual units. Because of their hardware independence, it is thus possible to develop software components without specific knowledge of the hardware used or planned, as well as to flexibly relocate existing software components to ECUs during development. On the other side of the runtime environment, the abstraction layer enables the development of competitive and OEM-specific software applications. On the lower side of the runtime environment, it enables the standardization and OEM independence of basic software.
So this was for the topic of AUTOSAR. So we've been here. Next news are in bridge circuits, where we enhanced the course by application examples. So I will go into bridge circuits on the page. So we have bridge circuits. The content is like some basic introduction. Then you have a balanced bridge circuit and the unbalanced bridge circuits and application examples. Target is to understand it for the industry. I will not go into all the details here. You also have a trailer, and here are the insights of some of the pictures to understand it better. And here, like always, you go into the course, and I opened this already. So here you see the bridge circuits course, and we can just start maybe with applications to have just a very short insight on how it's done.
Bridge circuits are used in various fields of application. The two most important ones are measurement technology and power electronics. In measurement technology, various bridge circuits are used to determine physical quantities. In power electronics, on the other hand, bridge circuits are used to convert electrical energy. On the following slides, you will learn about an example circuit for both fields.
I think this is enough information on bridge circuits. It's not a very complicated topic, but it's the basics you need in other areas. And if we look at some of the courses, you see that bridge circuits, like a basic understanding, is then needed to understand the deeper, more complex topics. And this especially is valid for the course on measurement technology, what we just heard, and power electronics fundamentals. So these were like the small updates. Now we are looking at the bigger chunks where we did bigger changes. There's a new course on charging communication between EV and EVSE, which I will have a look with you together into right now. Oh, this is this one, charging communication between EV and EVSE. The content is concerning the so-called low-level communication, pilot signal, and duty cycle, with the details about frequency and duty cycle you need to know about the low-level communication, the relation between duty cycle and the current, the schematic for the PWM signal and different charging states, and state A, B, and C in charging communication. And then there is the high-level communication with general high-level communication, a short introduction to the OSI model. A longer introduction to the OSI model is available in the introduction to serial bus systems. So if someone doesn't have the background in the OSI model, then it's useful to also have a look on serial bus systems. Then the the explanation physical layer in the charging communication. So everything connected to the OSI model is then also connected to charging communication, and then so the so-called Slack communication via the data link layer. So we can have a short look into this one as well. Starting with the, I don't know. I've been in this window before, resume.
Let us now have a look at different charging.
So EV charge.
Pilot signal is a mandatory part of EV charging. It provides communication between the vehicle and the EV charging station by using a PWM signal. The EV charging station communicates the available predetermined charging current via the duty cycle of a 1 kHz PWM signal, while the vehicle communicates by varying the voltage level of the state of charge. The pilot signal forms the basis for any kind of signal link between vehicle and EV charging station.
So for the next one, important terms.
For communication between EV charging station and vehicle, the principle of pulse width modulation is used. Important parameters are frequency and duty cycle. The frequency is the number of periods in 1 second. It is given in hertz. A fixed 1 kHz PWM signal is used as a carrier signal for communication in EV charging. The duty cycle describes the ratio of pulse width to total period of the signal. It is given in percent. For communication, the EV charging station only varies the ratio of pulse and pause, and transmits thereby the available predetermined current.
So I think this is just like an introduction, but you can see how this is done. And as I said, it's a completely new course. So we are now going back to the portfolio page. And we see a little bit lower here, EV charging fundamentals, which now got an own course. And we can find this information here. It's a longer course with 4 separate e-learning units inside, going first into the basics, EV charging system approaches, AC and DC charging, then the modes according to IEC 61851/1. Then the power clusters and standards. Of course, you should know about the plugs because they're different wherever you look at. So Japan, China, US, and Europe have different standards. The charging dependency on the state of charge, and also some introduction to the bidirectional charging. Then we go into automated charging, magnetic flow. So first we introduce Nikola Tesla, then to understand the inductive charging and its types, the layout, the efficiency, and there are some auxiliary functions which you need if you do inductive charging, for example, for an object detection, and you need to position in the right way. And of course, there are benefits and drawbacks. Then there's the topic of automative conductive charging. The next one is on all the use cases. So it depends on where you're charging. Then usually you have more functionality or less. Like you have a wall box, you have AC charging station, DC charging stations. At home, you might not need to have all the know-how for payment options, so it's different. And you have then the last one is the e-learning on grid interaction to have an overall picture, because charging is not just happening where the plug is, no, the electricity is coming from somewhere, but it's the whole picture. And changing to e-mobility is also changing the picture of the overall grid. And especially if we are using electric vehicles in the future for bidirectional charging, to have them as energy storage. Yeah, so this is a short view on what content to expect. And this content I just explained before, you see also here with EV charging basics. And when you click in where the picture is, automated charging, charging use cases, and grid interaction. So it has the same structure. And I would now give like a short sneak peek to the system approaches.
I want to begin this chapter on charging by looking at the variety of different options we have for charging an electric vehicle. A very innovative approach is battery swapping. Hereby we don't charge the battery in the vehicle, but outside the vehicle. For this, we remove the empty battery and place a new, fully charged battery inside the vehicle. Hence, this is a very fast charging option. Another innovative topic is automated charging, which can be subdivided into inductive and automated conductive charging. Inductive charging can be further divided into static and dynamic charging. This topic will be discussed in more detail in the course on automated charging in the series on EV charging. As we want to focus on the basics of charging in this chapter, we will concentrate on the manual conductive charging of a vehicle. This means that we charge the vehicle by physically plugging the vehicle with a wire to an outlet. Here, we can distinguish between AC and DC charging.
Okay, this was a look also inside this one. So basically, these are like the big changes we did since last time. Of course, a full course takes some time. What's the outlook for and what's coming next? We are planning to add a new course on the topic of charging communication, because we would like to look into the encrypted charging communication, and I think it's a very special case, so it makes sense to introduce a new course on this topic. This currently is in work, and we are also working in the measurement area. Now, having finished the course on bridge circuits, we're working on measurement technology using strain gauges. On the basic course, we'll continue to add new content, and we'll publish also some new content within this year. I believe that we will not do what's new in December, because end of December would mean Christmas time. So we will have the next Embedded Academy What's New beginning of 2025. But this doesn't mean that we are not live until then. As I've shown before, we have a YouTube channel and often have guests for some technical talks. And most likely we will have at least Thomas Schütz again, but there could be also some updates on charging and maybe other topics. And of course, on the video side, we will continue to publish every Friday morning new videos, so there will be quite a lot of updates until the end of December. So maybe just a short look in here. So we will add videos in this area for the next weeks to come on different topics. Okay, so I would say thank you for joining, and I hope to see you again latest in the beginning of 2025. And I hope you enjoy our e-learning portfolio and that it really benefits you in your job. Thank you and bye-bye.